This video is going to cover how to graph an absolute value function. Let's go ahead and get started here. So we're going to start by determining how the absolute value function opens. We look at the number that is touching our bars. In this case, we have -1/4. If that number is negative, it's going to open downward. And in this case, it is negative, so it's opening downward. And that's because the right side of our graph would be negative, the left side would be positive, so it would be opening downward like that. Upward would look something like this. So this graph is going to open down because our A value, which is the number that touches our absolute value bars, is a negative number. Next, your vertex is going to come from this number, and it's going to be the opposite of -6. The opposite of -6 is +6. Some people like to say, what x value could you put in here to make what's inside the bars equal to 0? And obviously +6 would be that number, but I just say, let's take the opposite of the number that's in the bars and write it down for your x value. Your y value is just going to be the constant that's on its own. Typically, it will be in the back of the equation like it is here, and you're just going to leave it as it is. So again, opposite of your x value, this is your y value. Your delta y over delta x is this number right here, but it's positive and negative because we think about absolute value graphs, they open upward or downward and they're V-shaped. So half of it has a positive slope and the other half has a negative slope. So it's going to be positive and -1/4. The axis of symmetry equation might make more sense when I graph it, but it's always going to be x equals the x value from your vertex. And the x value from this vertex is 6. So I'm going to say x equals 6. This might make more sense once I graph it, but let's go ahead and graph it. We're going to start at our vertex, which is 6, 2. So I'm going to go over from center 1, 2, 3, 4, 5, 6, and down 1, 2. And that's because I'm at -2. From there, we know it opens downward because we had a negative slope. So on the right side, I'm falling 1. Instead of rise over run, I'm falling because it's negative. So I'm going to fall 1, run 4. I'm going to go back up to my vertex, fall 1, go to the left 4. And this will make my mirror image. Fall 1 to the left 4. Fall 1 to the left 4. Once I have that down, I can draw in my lines and my arrows, and I have an absolute value graph. My next question asks what my x-intercepts are. Because the vertex is down here at 6, -2, so it's below the x-axis, and I have a negative slope, meaning it opens downward, I actually have no x-intercepts because it doesn't cross my x-axis, which is right here. So my answer would be no solution. My y-intercept is right here. You can tell it's a fraction and we can't exactly see what it is perfectly. So to find your y-intercept, so I'm going to write this down. To find your y-intercept, you plug in x for 0. So for the y-intercept, your x is 0. So in my original equation, I'm going to plug in 0 for x to find my y-intercept. And remember your h of x, don't freak out about it. I know it looks complicated. H of x just means y. So what I'm going to do is I'm going to say y equals -1/4 times the absolute value of 0 minus 6 minus 2. So again, I plugged in 0 for x because I'm trying to find my y-intercept. You have to do what's inside of your absolute value bars first. So inside of our absolute value bars is 0 minus 6, which is just -6. Next, you're going to take the absolute value of -6, and the absolute value of -6 is +6. You might be confused why I changed those bars to parentheses, and I just want to explain that -1/4 is touching your absolute value bars, meaning it's multiplying by them. So once I take the absolute value of -6, I'm still multiplying the -1/4 times it. So that's why it's still touching there. If you're not sure how to do -1/4 times 6, I encourage you to do -1/4 times 6 over 1 off to the side where you have room. -1 times 6 is -6, and 4 times 1 is 4. If you reduce that, it's -3 over 2. So we'll have y equals -3 over 2 minus 2. You can't reasonably subtract 2 from -3/2 because it doesn't have a common denominator. So instead, we're going to do -3/2 minus 4/2. and negative 3 halves minus 4 halves is negative 7 halves. So our y-intercept is going to be 0, negative 7 halves. Now we have to find the symmetric point to the y-intercept. So my y-intercept's right here. My symmetric point, which is the exact opposite, is going to be somewhere over there. And we know it's the symmetric point because our axis of symmetry crosses straight through the middle of my vertex. And my equation for the axis of symmetry is x equals 6 because it crosses my x-axis at 6. So x equals 6 happens to be the number from my x-axis, and it happens to be the line that gives me my mirror image. So those red dots are mirror images, like they're equidistant away from my axis of symmetry. So to find my symmetric point, I'm going to start at my y-intercept, and I'm going to count 1, 2, 3, 4, 5, 6. Sorry, I miscounted here. Let me try this again. 1, 2, 3, 4, 5, 6. 6 squares to my axis of symmetry, and then I'm going to go 1, 2, 3, 4, 5, 6 squares to my symmetric point. So the x value from my symmetric point is 12, and I haven't moved up or down at all. So I'm still at negative 7 halves for my y value. If you're struggling to figure out your symmetric point, I'll give you a hint. Your symmetric point is always double the x value from your axis of symmetry. So double your axis of symmetry. And then it's the same as your y value in your y-intercept. So same as y-intercept for your y value. Okay, hopefully that becomes a little clearer as we do a few more problems. I have 3 more for you guys, and they continue to be challenging just like this. We're going to graph this one, okay? So we use the number that's touching our bars, that's our a value, to determine how it opens. It's a positive number. Sorry, let me go back to, I want to keep that erased so we have a little bit more room here. We have a positive number, so that means it's going to open upward. So the positive number means it opens upward. Our vertex is the opposite of negative 3. So the opposite of what's in the bars with those x is going to be positive 3. And then we're going to keep the y value, which is negative 6. Our slope here, or our delta y over delta x, comes from this number right here. And it's positive and negative 4. Or if you want to write it because you like your rise over run, you might want to write 4 over 1 because that's what we're actually going to do on our graph. The equation for the axis of symmetry is going to be x equals 3. Again, it's x equals the x value from your vertex. Let's go ahead and graph it. I'm going to start at 3, negative 1, 2, 3, 4, 5, 6. That's where my vertex is. From there, I'm going up 1, 2, 3, 4, and over 1. Up 1, 2, 3, 4, and over 1. Keep going until I run out of room here. Should end right at the top there. The other side's going to meet a mirror image. So I'm starting at the vertex, going up 4 to the left one. Up 4 to the left one, and I'm going to keep going until I run out of room. All right. This graph does cross my x-axis. This graph crosses my x-axis at 2 points. One is right here, and one is right here. Let's talk about how to find our x-intercepts. So we just found our y-intercept by plugging in 0 for x. To find your x-intercept, so for your x-intercept, you're going to plug in 0 for y. And we don't have a y here, but remember h of x is the exact same thing as y. So we're going to say 0 equals 4 times the absolute value of x minus 3 minus 6. To solve for x, we have to isolate the absolute value bars and everything inside of them. So we're going to start by getting the absolute value bars by themselves. In the way of the absolute value bars being by themselves, we have 2 numbers. We have 4 and negative 6. The 4 is multiplying, the negative 6 is, we're just subtracting 6 there. So I'm going to start by adding 6 on both sides, and I'll get 6 equals 4 times the absolute value of x minus 3. Then I will divide by 4 on both sides, and I'll get 6 over 4. 6 over 4 reduces to 3 halves. So I'm going to have 3 halves equals the absolute value of x minus 3. Once we get here, we're going to break it into positive and negative solutions. So on the positive side, I'm going to have 3 halves equals x minus 3. And on the negative side, I'll have negative 3 halves equals x minus 3. I can't reasonably add 3 to both sides because they don't have a common denominator with 3 halves. So instead of adding 3 to both halves, I'm going to add 6 halves to both halves. And that's because 6 divided by 2 equals 3, and it has a common denominator with my fraction. So my first one is going to be 9 halves, comma 0, and that's on the positive side. That checks out. That's about 4.5 right there, which is the same thing as 9 halves. So I think I got it right. And then over here, when I add 6 halves and add 6 halves, on the negative side of my graph, the negative slope, I'm going to have 3 halves equals x. So it should be about 1.5, and that's exactly where I am. So I will have a second x-intercept of 3 halves, comma 0. Now the y-intercept should be very easy to see here. I'm going to highlight this in blue. It's where it crosses my y-axis. My y-axis is the up and down axis. So I should be able to count that. It looks to me like it's 0, 6. So this point in blue right here is 0, 6. On this graph, it is extremely easy to see the symmetrical points. So let me do this like light purple color. This point right here is symmetrical with this point. This point is symmetrical with this point. Our x-intercepts are actually symmetrical, and these 2 points are symmetrical. That's because we can split our graph right in half at x equals 3. That x equals 3 axis of symmetry is basically where the mirror image happens. So when we're looking for a symmetric point to the y-intercept, we can look at the y-intercept, use the axis of symmetry as our mirror, and figure out what the opposite point is. Some of you might be able to see that it's 6, 6 right away, but if you can't, you can always count. This is 1, 2, 3 squares away from the axis of symmetry, so I have to go 1, 2, 3 more squares over to reach my symmetric point. As a reminder, your symmetric point is double the value of your axis of symmetry. So double the number 3, which is your axis of symmetry, and then same as your y value from your y-intercept. So same as the y value from your y-intercept. And that'll work every single time. Okay, we got 2 more. On this graph, we are going to be opening down. And the reason we're opening down is because that a value, which is touching our bars, is negative. So this one opens down. Our vertex is the opposite of negative 6, which is positive 6, and then positive 3. So we'll have a positive 3. Our 2 slopes come from this value right here. So we're going to have a positive slope and a negative slope depending on what side of the vertex we're on. So half of our graph is going to be going up 4/3, and then the other half is going to be going down 4/3. The equation for axis of symmetry will be x equals 6 because it's x equals the x value from your vertex. Let's graph it. We're going to go over 1, 2, 3, 4, 5, 6, up 1, 2, 3. So our vertex is right here. We're opening downward. So we're going down 1, 2, 3, 4 to the right 1, 2, 3. I can't fit any more on the right side, so I'm going to go down 4 and go back 1, 2, 3 on my left side. Down 1, 2, 3, 4, back 1, 2, 3. Down 1, 2, 3, 4, back 1, 2, 3. Perfect. You can see your axis of symmetry right away is going to be at x equals 6, like we had said. So it's cutting straight through the middle. That's going to be where your mirror image happens. So that's going to be x equals 6. You do have 2 x-intercepts, but yet again, your x-intercepts are fractions, right? So there's going to be one about right here and one about right here. Let's calculate what your x-intercepts are going to be. As a reminder, to find your x-intercept, you have to plug in 0 for y. Plug in 0 for y. So we're plugging in 0 for h of x here. We're going to say 0 equals negative 4/3 times the absolute value of x minus 6 plus 3. We have to isolate our absolute value bars by subtracting 3 on each side. We'll get negative 3 equals negative 4/3 times the absolute value of x minus 6. To get rid of a fraction coefficient, so we're multiplying by a fraction, you can multiply by the reciprocal, which is -3/4. If you can't do that in your head, you can do -3/4 times -3/1. -3 times -3 is +9, and 9 times 4 is 4. So we're going to have 9/4 equals, our fractions here cancel, and we'll have the absolute value of x minus 6. Next, we'll break it up into a positive solution and negative solution. Bear with me, we're going to get some wacky numbers here, but they're all going to work out. So on our positive side, we're going to have 9/4 equals x minus 6. And on our negative side, we'll have -9/4 equals x minus 6. Instead of adding 6 to both sides, I'm actually going to add 24 divided by 4, because 24 divided by 4 gives me the common denominator of 4, and it still equals 6. So I'm going to add 24/4 on this side, add 24/4 on this side, and I'll get 33/4 equals x. So on my positive side, my x-intercept is 33/4, 0. And then on my negative side, when I add 24/4 and add 24/4, I am going to get, 15/4 equals x. So I will have 15/4, 0. Those are my two x-intercepts, kind of wild fractions, but hopefully you are following. I'm going to do my y-intercept in pink. It's where it crosses my up and down axis right there. And you'll notice our symmetric point is invisible. It's off the graph there, so it goes too far. We're going to start by finding our y-intercept, which is down 1, 2, 3, 4, 5. So it'll be, let me double check that. 1, 2, 3, 4, 5. Yep, so 0, -5 is our y-intercept. Then we are going to need to find that symmetric point. So to get to that symmetric point, we were 1, 2, 3, 4, 5, 6 squares away from our axis of symmetry, meaning we'll have to go 1, 2, 3, 4, 5, 6 more squares to our symmetric point. It's also double your axis of symmetry value, so it'll be 12, and then you keep the y value the same. It'll be -5. So 12, -5 is our symmetric point. Let's do one more of these to close it out. Okay, we are going to start by looking at this value to see which way it opens. That value is positive, so it's going to open upward. Our vertex is going to be the opposite of +2, which is -2, and then you're going to have -3 after that. So your x value is -2, your y value is -3. Your delta y over delta x is positive and -2. If you would like to write it as 2/1, feel free to. Your axis of symmetry is going to be x equals the x value from your vertex. So it's going to be x equals -2. Let's graph it. From the center, I'm going back 2, down 1, 2, 3. That's my vertex. Vertex right there. From there, I'm going up 2 over 1. And remember, this opens upward. So I want to make sure my right side has a positive slope. Then I'm going to make a mirror image on my left side. So I'm going to go up to left 1. Keep going until you run out of room. And then when you're finished, draw in your lines and your arrows. Now I can fit in my axis of symmetry. So my axis of symmetry is going to be straight through the middle. And like we said, it's going to be x equals -2. And you know it's x equals -2 because it crosses your x-axis at -2. Sorry, I'm hitting everything but what I want to. There we go. X equals -2. Good. Now our x-intercepts are yet again fractions. So let's go ahead and solve it. We're plugging in 0 for y, and y in this case is represented as h of x. So we are going to say 0 equals 2 times the absolute value of x plus 2 minus 3. Add 3 to both sides because we're trying to get the bars by themselves. We'll get 3 equals 2 times the absolute value of x plus 2. We'll divide by 2 on both sides, get 3 halves equals the absolute value of x plus 2. Once we get here, we'll break it up into a positive solution and a negative solution. So we'll have 3 halves equals x plus 2, and then -3 halves equals x plus 2. Instead of subtracting 2 on both sides, I'm going to subtract 4 halves on both sides. And again, I'm doing that because I want a common denominator, and 4/2 is the same thing as 2. When I subtract 4/2 on my positive side, I get -1/2. When I subtract 4/2 on my negative side, I'm going to get -7/2 equals x. So my two x-intercepts are going to be -1/2, 0, and -7/2, 0. That is about a half. Yep, so 1/2 would be right here, and -7/2 would be 3.5, which is right there. So that checks out. Our y-intercept, I'll highlight in this bright green. It's going to be where it crosses my y-axis, and that is 0, 1. 0, +1. My symmetric point, you should be able just to see. It's the opposite point right there. If you're not able to see that, you can always go 1, 2 squares to the axis of symmetry, 1, 2 squares. And keep in mind, we're going to the left, so we're going to the negative side. So double our -2 is going to give us -4, and the y value from our y-intercept was 1. All right.